We are finally on to our last segment tonight, and we are more or less on time. We knew we'd go a little bit long tonight because we're bringing you an additional segment about Apollo 15. Indeed, it has been 50 years since Apollo 15 went to the moon. We are celebrating the 50th anniversary. We've been celebrating most of the 50th anniversaries of the Apollo missions. COVID threw us for a little loop that had to have us merge them into All Space Considered due to all sorts of stuff, but we are following through, and tonight Chris Butler is here to tell you about some of the amazing things that went on during the mission. And then afterwards, I will explain to you why it would have been really, really difficult to hoax. Some of you that have seen that before, I'll go through it quickly, and I have some new material, but it's always fun to tell people why it's harder to hoax going to the moon than just going. But Chris, what was Apollo 15 all about? And it looks like we brought a car with us this time.
We did indeed. And I think the number one takeaway for everybody is not just another moon mission. The last three, 15, 16, and 17, were a sudden jump up, a big jump. People who were alive at the time remember watching it, this was a total transformation of what Apollo could do. And why is that? Why were we doing all these new exciting things? Well, I like to put it like this. In my opinion, this is when Apollo grew up. The first few flights were just tests to see if the system worked. Of course, they gathered samples and they tried to do some science, but they were still refining and perfecting the vehicle. This is only Apollo 11, 12, 14, 13 didn't land, of course. This is only the fourth landing on the moon. So it's not surprising. They were still working on the vehicles, making reductions in the amount of weight so that they could carry more. And here's one of the big payoffs, the lunar roving vehicle. We could carry it on 15. Earlier landers were just too heavy. They couldn't carry the payload, and the vehicle was in development. But the main thing is we were refining Apollo. What does a rover do for you? Why is that a big deal? Think about it. The earlier astronauts on 11, 12, and 14, they had to walk. They had to walk everywhere they went. And that means you can't go very far and you can't go very fast. And the oxygen's running out in your backpack the whole time. Going fast helps in every possible way. It was a huge difference. And also, while we're at it, the spacecraft in orbit, Endeavour was her name, she's crammed now with science instruments that were put in a part of the service module that wasn't used. Why were they able to do that? Partly weight reductions in the vehicle opened up payload capacity so they could put huge tracking cameras in there, spectrometers, magnetometers, all kinds of different things. And they even were able to pack in a sub-satellite, a sub-spacecraft. You can see it next to the command module there. It's the thing with the 3 antennae on it. They ejected that into orbit around the moon to conduct research into the moon's gravitational field. And it wasn't just even the vehicles. The tools we were using on the moon had improved. Why? Well, the scientists had new ideas. That's part of it. But also the experience of the astronauts. This is the fourth landing. Astronauts had come back and said what they needed, what worked best, what they should try. And the rake that you see on the left, for example, that was partly devised by the astronauts working with the geologists for how to grab lots of pebble-sized samples quickly. You just run the rake through, it strains them out, and a good development. And on the other side, you've got Dave Scott. That's an actual picture from Apollo 15. And he's carrying a camera, but if you look, it looks longer than usual. The reason for that, Dave got the idea we need a telephoto lens, a big one, a 500 millimeter telephoto lens. That's like a small telescope. What was he doing with that out on the lunar surface? He was taking detailed pictures of things they couldn't get to. There wasn't time for. They were farther away, or like the tops of mountains where they couldn't get to it. So lots of improvements in that as well. Now that Apollo's grown up, where do they want to go? Now that we can go more places, which Apollo now could do, it could reach higher latitudes north and south than it had before. The scientists rolled out their list of, all right, you're done practicing. Now we're going for the most important sites on the moon. One of the idea was craters. That was a big idea. Why? Craters are like a drill hole. It digs material up from deep inside the moon and brings it up. Now, Tycho crater, early favorite, talked about throughout Apollo, but the floor was too rough. Tsiolkovsky crater had a flat floor, but unfortunately it was on the backside of the moon. And without a relay satellite, we wouldn't be able to talk to the astronauts. And NASA was nervous about depending on the relay. So Tsiolkovsky was out. Alphonsus Rill and Alphonsus crater was an example of one of dozens of places that were proposed. But for Apollo 15, the first one with the lunar rover, the big step up, it came down to two candidates. One of them, shown on the left, is Marius Hills. Marius Hills is flatter. It's safer to land. Now, the things that look like little pimples there, they're actually, of course, big. Those are several hundred feet high. Those are dome volcanoes. We still believe today they're some of the last volcanic features that formed on the moon. And looking for volcanic features is something they wanted to do, but the main attraction is it's a lot safer to land there. The other site, the one Hadley Apennine on your right, you don't need to be a rocket scientist to see how much more difficult it would be to land there. The terrain is much rougher. Those bumpy looking things next to the X marks the landing spot, those aren't little bumps. Those are mountains 15,000 feet tall. It's incredible, the thought of flying over those and then come through a landing. If you look next to the X on the other side, you'll see a little winding snake-like depression. That's a rill as well, a volcanic feature, and it's 1,000 feet deep. So between mountains and the rill, you have to do a precision landing there. The astronauts in the end made the decision this site was so important, they would have to go there. And so Hadley Apennine was chosen. Now, remember I said that craters would dig things up. Absolutely. Tycho would have dug up some things, Copernicus, Tsiolkovsky, any of them. But if you look at the moon tonight yourself or on a full moon night, you'll see the big circular patch marked on the left there. That's Mare Imbrium, the Sea of Rains. It's circular in outline for a good reason. It is the remains of a gigantic super crater. We call them an impact basin that formed on the moon very early in its history. And our landing site is right on the edge. Those mountain ranges are actually the rim of the crater. So what could they find there? Maybe the oldest rocks on the moon, maybe the original rocks. Hadley was a big, big deal. So the scientists trained the astronauts more than they ever had before. They had them just absolutely fall in love with field geology. I want to show one guy from Caltech, a shout out for our friends at Caltech. In the black and white photograph, the gentleman wearing the hat is Dr. Leon Silver of Caltech's geology department, taking the astronauts out and helping them fall in love with field geology. How did it go? Well, it went very well. This is no Apollo 13. We were able to do what we wanted to do. There's a picture of Jim Irwin standing on the moon with Mount Hadley Delta behind him, again, like 13,000 feet tall, the lunar module Falcon, and you can see the lunar rover. Did it work? Yes, actually the lunar rover worked quite well. There were a few little hiccups, but it was able to transport them all the way out to the rill, not just to the rill, but even over the rim, where we found some of the only lunar bedrock, not a rock that was blasted out by a crater, but that cooled off right where they found it in its original spot. That's one of the few times we've ever seen that on the moon. And we also found the very famous, you probably heard of it, Genesis rock. They think they did find a piece of the moon's original first crust when it first cooled off. Incredible find, but that was what we expected from Hadley. We also all got to enjoy it because there was a television camera on the rover. Both the public and the scientists could follow along with the explorations of the astronauts, so it felt like we were all along for the trip. And while we're at it, they did some unusual and fun things we usually did when we went to the moon. In this case, you see this envelope has stamps on it. It also has a little smudgy gray stuff, which I will tell you is moon dust. And the stamps, they're a little hard to read, but they actually say that this stamp was canceled on the moon. This is the only time you've ever had a letter mailed from the moon. And then lastly, just wrapping it all up, what did it do? 170 pounds of samples. Apollo 14 brought back 93. And among those 170 pounds were possibly a piece of the moon's original crust. The results were incredible. The scientists were delighted. The astronauts performed much more complex, brand new, improved science experiments when they were on the surface and in orbit as well. And they also paved the way for Apollo 16 and 17 by proving that the new, improved kind of super Apollo would really work. So we owe Dave and Jim and Al there a huge vote of thanks. They cast a legacy that will last far, far, far into the future. It looked like science fiction, but it did really happen. I'm going to say it really happened. But now, Dr. Reitzel, you're going to shoot this down, say it didn't happen?
Well, maybe. I've got some ideas.
Okay.
You know, set up a sound stage, have Doge come direct it, put some wires on an astronaut, bounce them around, look like it's low gravity. Right. You know, stick a few light sources on there to create the shadows, and you got yourself a nice movie. It's easy to do, just like that. Well, to do it, what do you really have to do? Well, they made a bunch of hardware, of course. Engineers worked on all that hardware. We built the largest rocket ever. There was only today, literally today, is the first day that a larger rocket was stacked than the one they built and showed off to people. They built capsules that were capable of carrying people in them. This engineer here, he knew this thing would be, the people in there would be safe. He helped them into the capsule. He believed it all. Or somebody would pay him off and he would say it didn't happen. More engineers working on the lander, and indeed you can see our little friend, the rover, hanging out right here being loaded onto it. But they built all this hardware and they believed it would work. They tested it on the ground. So basically you've built everything that could get you to the moon. All these people really thought it would happen. All the readouts on all these displays, all the printouts, all had to be faked to show we were sending people to the moon, because all these engineers expected to see the readings that would tell them they were on the way to the moon, or they're all in on it. And do you think they all kept their mouths shut? I doubt it. Nobody can keep a secret these days. We launched these things. People saw them go up. It wasn't, the Soviet Union, I'm sure, had spies on hand on the Florida coast watching these things go up. They could fly in. There was no issue. Just get on a plane, they'd fly in and watch it. People observed things happening in space that were consistent with what we expected to happen from those rockets. Things like separations, second stage ignitions, all that sort of stuff was observed from the ground. The panels of the service module blowing off, where there were 4 of them. You'd expect in this artist's conception to look a little like that. Well, here's the actual picture of it from the ground. Those trails, by the way, are star trails. You have to track the spacecraft on its way to the moon. So if it's not going to the moon, you won't get this picture right. So even this, can't fake it. The Soviet Union, like I said, they had a large interest in making people know we were faking it. And they had very large ships with big radio dishes. And in order to pick up a signal, you have to point it at the spacecraft as it's going to the moon. So we had to fake signals from a spacecraft on the way to the moon that was responding to questions being sent from the ground sounding like live transmissions. So now you're faking television programs and radio programs coming from a spacecraft that's on its way to the moon, and it has to be doing that because the Soviet Union would have said it's not coming from there. So literally, if it were faked, we still had to somehow can all of this, put it all on a tape drive and send it on a robotic graft. I mean, it's starting to get really hard to make all this work. Not only that, we had huge warehouses with immense amounts of gray dirt that we had to have these, paint these huge scenes, truck it all in. It's okay, it's not all gray, actually. I'm seeing some red dirt, some kind of almost black dirt. There's different colors. So they just didn't get one source. They just didn't fake it. You look at those backgrounds of old Star Trek episodes, and I love the Star Trek series, don't get me wrong, but you can tell that it's a studio a lot of the time, well, unless they were out at the Vasquez Rocks, of course. The Gorn was actually there near LA at a site that's great. You can see here, they drove the car around getting different perspectives of those mountains in the background. So not only did they have to paint these huge matte paintings to do the back warehouse walls, they had to have different ones that changed perspective as they drove the car around to make it look like they were going large distances in this vehicle. So where are all those matte paintings? What did they do with them all? Who's the guy that painted them? Where's the woman that sat there and painted all this stuff? Those people want recognition. I don't think they're being quiet. Now you're going to say, where are the stars? This is all fake. There are no stars here at all. Well, here's a picture we took of the front of Griffith Observatory with a camera. I don't see any stars. Right, you say, well, clearly you didn't expose long enough. It's silly. Okay, we'll expose a little longer. Picture's a little better. Still not a great picture of Griffith Observatory. So we exposed a little bit longer. And now indeed, we have a pretty good picture of the front, but it's starting to get overexposed. Those lights are a little too bright, but we are seeing clouds. And now if we go a little bit more, a longer exposure, you can see our beautiful cupola up there. You can see the dome of the Samuel Ocean Planetarium in the background. And the clouds are quite nice. There's even what looks like a couple of spots from probably movie premieres or something in the sky up there, but we've lost all the detail here in the front of the building. It's completely what's called overexposed. So you can't, even with a modern camera today, and I think we took this in 2014 probably, or maybe 2016. Anyway, modern cameras today, relatively modern, can't get very bright things and very faint things at the same time. Do you think back in the late 60s, early 70s when we went to the moon, we would expose long enough to get the stars and still be able to see the moon and the earth? No. You go to the moon to get this picture. You don't go to take pictures of stars. It would ruin the foreground picture. Now you might say, well, shadows are going the wrong direction. What about that? It shows they're using spotlights and everything's wrong. Well, here's a shadow going this direction. Here's a shadow going this direction. Okay, so maybe there's a light source off that direction and another light source off this direction. Still confuses me because you should have multiple shadows, but maybe some magic is going on here that's making the multiple shadows not happen. But I was on my walk up to Griffith Observatory the other day, well, the other year at this point. These shadows aren't going the same direction. This is just a couple of poles on the walk up. This is called perspective. We figured this out in the Renaissance when we were painting things. Also, again, the shadows. Yeah, give shadows and poles go in different directions. Some of this is the fact the land has different relief, different elevations. Some of it is just perspective, the way that it works when you're imaging things. So if you know how reality works, the shadows on the moon are not a problem at all. We've left instruments that bounce radiation back directly where it comes. Think bike reflector. You know what it all is like. You have a bike, you see the bright, it looks like the lights are shining, but it's really coming from your own car headlights. Well, we left those on the moon to bounce lasers off the moon to see how far away the moon was. It lets you measure the distance. Well, if you point to the right spot, you get a reflection. If you don't point to the right spot, you don't. You have to point where we left them. And we left them at the Apollo landing sites. We also brought back a lot of rocks, like Chris was saying. In fact, this is the rock that was brought back Apollo 14, I believe, that our Big Bertha sample is from at Griffith Observatory. We own a chunk of one of those rocks you're looking at. Well, we don't own it. We have it on display. It is leased to us from Griffith Observatory, or from NASA. And my cat's causing trouble now here, so let me fix a couple of things. Anyway, what's interesting about them is all these rocks, if they're exposed to the surface, show these little micro meteorite impacts, little tiny craters. You don't get those on Earth because our atmosphere burns up the little grains of sand as meteors. The Perseid meteor shower leaves little tiny impact craters on the moon. On Earth, it burns up and gives us a beautiful meteor shower. So evidence these rocks came from the moon. Now you might want to say, show me pictures. Some folks wanted to know. In fact, our question of the night from our foundation from Lisa Torres was, when we send the first woman to the moon with the Artemis program, are we going to be able to see her from Griffith Observatory with our telescopes? Well, unfortunately, no. You need a telescope something like a mile wide in order to get that sort of detail. And you'd likely have to have it in space because the atmosphere blurs things so much you can't see that sort of detail. In fact, we had to send a spacecraft called the Mars Reconnaissance Orbiter, which has about a 12-inch telescope on it. It's about the size as our Zeiss telescope on the roof of Griffith Observatory. We sent it into orbit, and it's a fairly low orbit, and it's getting these sorts of pictures from the landing sites. You can see that the land is disturbed. You can see some of the stuff we left behind. In fact, here's a zoom in of the Apollo 17 landing, actually. You can see the descent stage. You can see the Challenger descent stage, the ALSEP equipment. Again, that's the science equipment that's left there. Geophone rock, they've named a rock that. And on top of it, all those little tracks that are doubles, those are car tracks left by the rover that was there. They took with it on 15, 16, and 17. So we can't see an individual person. It might look like a little dot bouncing around from a telescope like MRO in orbit. But it's a great question from our foundation. And I encourage all of you that want to have one of your questions appear at All Space Considered, join the foundation. It's a great way to get involved. We have special events. You too can participate with Griffith Observatory. Anyway, lastly, Apollo 15 ran a science experiment on the moon, and they got footage of it. The footage isn't great. Remember, this is a television camera, an old school television camera. The low res stuff that, well, I remember it. A lot of you younger folks don't know what low res television was like, but go to Hulu or something and put on an old show that was from the 50s, and it'll look a little blurry in your modern 2021 TV. But take a look at this. I'm just going to let it run. And this is an experiment, and it's all very well explained. So enjoy this look.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
So Mr. Galileo was correct in his findings. Now notice, that shows a few things. A hammer and a feather fell at the same rate. Now you might think, okay, what's the big deal? Well, go drop a hammer and a feather here on Earth.
Can't do it here.
The hammer's gonna, just fall down and hit your foot probably. Well, if you're me, it might. So that showed there was no atmosphere. You're testing it without the atmosphere. The two fell at the same rate and hit. Now on top of it, they still fell more slowly than they should. So either they slowed down that footage in a room that had all the air pumped out of it. That's how you had to fake that. You had to have a room big enough for them to jump around in and move, and there had to be wires on him too, because they're all kind of moving slowly and funny. And then they had a hammer and a feather, and they drop them. And if there were air in the room, the feather would have fluttered, and there was no fluttering, it just fell. Or maybe they made a magic feather out of lead, but the feather kind of flopped around when he moved it. So it had to be anyway, the whole thing makes no sense to do it here on Earth. That really shows it was on the moon. It's hard to fake this stuff. It's just hard to fake it. You can't get the physics right. The dirt that's kicked up when the astronauts bounce around, it poofs up into the air, falls unusually slow, and is gone. There's no dust cloud left. That doesn't happen where you have atmosphere. So all this footage we're seeing has to happen without any atmosphere. And we couldn't make giant pumped out vacuums the size of stages. It can't be done. You can only make them so big. So anyway, you can't fake this stuff. A lot of folks say, well, then why didn't we go back? You had to have faked it, otherwise you would have gone back. Well, first of all, we did go back. Apollo 11, 12. We faked one that we failed. Why would we do that as a nation? Let's fake a failure. Oh, to make it more realistic. Sure. 14, 15, 16, 17. So we did go back. We went back 6 times successfully and 1 time in a failure. Now, on top of it, look at the budget as a percentage of the federal budget. So it does change. This isn't raw numbers at all. But you can see it was a big, important thing for us to do in the mid-60s. As soon as the hardware was built, the funding started to dry up immediately. And by the time we're actually going late 60s, early 70s, it's about half of what it was when it was at its peak. And then you drop into the 70s and 80s and you're down under 1% of the federal budget. It's right now about half a penny for every dollar you send in your taxes goes to NASA. Yeah. So folks that want to say the space program's too expensive and we should be cutting things, this is not where we're wasting money, folks. NASA's pretty cheap in the long run. And you noticed all the stuff we did. Well, we did Apollo Soyuz. We did that. We had the space station. We had, the early Skylab space station. We ran the shuttle. We built the International Space Station. We launched the Hubble Space Telescope, a bunch of other stuff, all with this budget. So if you want to go to the moon, which we're doing now with very small amounts of money with Artemis, which is why it's going rather slowly, it takes money to do it. It just does, and it takes dedication. And I believe we have the will to go back now. I really do. I think we're going to get back there. I think the hardware is being built. I think SpaceX and Elon Musk and his team, with their rapid development, we are in for some really exciting times. So I do think we went to the moon. I think we did. I think we left boot prints. I think we left tire tracks. I think we brought back a whole lot of samples you can't explain otherwise.